properties of logs.
Let me remind you,
Word log, logarithms, we are thinking of these as they're associated with this.
exponents. Now let's go back to middle school. We're going to do that field trip soon, because school's going to be out pretty soon. We've got to walk across the street and visit that school over there, see what they're doing.
If you're in middle school,
Let me remind you of the three major properties you should remember
for middle school, about exponents. If you saw this,
please remind me, that's a raised to the m times a raised to the n. Does anyone remember what's allowed to be done here from middle school with exponents? Yes?
And say that lost
a raised to, keep the base, and you're telling me I'm allowed to add them.
Is that true? That's from middle school. Now, I need a volunteer. Can someone read from that handout the first property of logarithms? And I'm going to write that right underneath this property from middle school and see if it makes sense. Who would like to read for me? Need a volunteer. Shane, go for it.
Product property is log sub A of m n
Okay?
is equal to log sub A of m plus log sub A of n.
Beautiful. You say, Professor, if I walked across the street and I
Told the kids across the street that, they would be shocked that we're saying, essentially we're saying what they're doing over there in the red. They're thinking of it as the red, a property of exponents. Now, I've got a property of logarithms that Shane read to me. Now, let's see if it connects with what they're doing across the street.
Shane, you told me this is a product. So they call this, middle school, you probably remember, this in the red was called the product property for exponents.
That's true, guys? Now, did I give a name to this on your handout for the blue one? Did I actually give a name to it or not?
Yes, product property.
Product property. Same as the middle school, written a little differently here. By the way, that's a product. It says if you have a product, you are allowed to split this up and add these. And these are exponents. So I'm doing the same thing you did in middle school.
Now, number two, I'm doing the red. There's only three of these guys. Back in middle school, if you saw this, you did this.
I hope. You were allowed to subtract the exponents.
And I think they identified that back then as the quotient property. Now, Shane, do me a favor. Would you now tell me what on the handout does this look like in blue for the logs?
It is log A, sub A of m over n.
Okay. Equals?
Is equal to log sub A of m minus log sub A of n.
Look at that. We're saying the same thing as the middle school kids.
If you have a quotient, you're allowed to subtract. That's what they're doing across the street. Same thing. Now, the one that might look a little strange is the last one, and basically, though, if you take a close look at it, we're saying the same thing.
Number three, I'm gonna write from middle school, one that looks like this. A raised to the m raised to the n.
What were you allowed to do back then? Add them? No, I have the product property already. That's where you add them. Quotient? No, it's not quotient property again. What are you allowed to do here? You're allowed to multiply them together.
Call this base A raised to the m times n.
Now, when Shane reads to me from the handout what this looks like, referring to logs,
I'll put it on the side here, guys. Shane, go for it.
Log subscript A of m superscript r
Oh, they call it R, okay.
is equal to R log sub A of M.
There you go. Guys, we'll call this the power property. Talking about powers here, work with. So I have all the properties I need for middle school rewritten for us across the street here with the logs. By the way, this last one says, guys, that's an exponent. It says just merely move that exponent out front and multiply it times the log, which is essentially another exponent. So you got two exponents being multiplied together, and that's what they're doing across the street. They're multiplying those two exponents together. That's what you're doing, R and the log together. Those are your properties. Okay, product, quotient, power. Now, there we go. On the side. Shane, you're doing a great job for me. Tell the class, read from there, what we're supposed to do now with the help of those properties.
Use properties to rewrite the expressions.
Okay, rewrite, and what did I have?
The first one is ln,
Oh, okay, natural log, okay.
of, this is a big one, it's 5x square root
Whoa, 5x square root,
1 plus 3x over,
whoa,
x minus 4 in parentheses, cubed.
cubed.
Yeah.
Cubed. And guys, again, if they use the abbreviated form LN, they mean a natural, they call it natural log. I understood the base is understood to be an E, if they use LN rather than LOG. But these properties still apply. Now, I'm supposed to use those properties and split this thing up. Here you walk into a Math 7 class, and when I teach calculus, and I give them a long, drawn-out problem, and ask them to do a calculus technique on it, you cannot do it on the original. And you'd be there forever. So what you're going to do first is use your pre-calc and break it down to smaller parts, then apply the calculus to the smaller parts. Guys, the smaller parts here would be for me to break that down with the help of these properties into smaller parts. Now, which of these three properties might you, the way it looks, start out with? The product, quotient, power. It is a quotient. So let's start out with the quotient property. That means I can split them up like this. Take the ln up, and I'll be very patient. The top numerator, she gave me, and subtract ln, natural log, of the bottom part, denominator, and you get this. I'll give you partial credit for all this when you finally see all of it. That's the quotient property. Now, can I go further? Okay, next, looks like, please tell me, remind me, is this a product altogether here? Does it say 5 times x times that square root? Since it is a large product, why not now apply the product property? Which means I can now, with the help of the product property, split those up into ln of 5 plus ln of x plus ln of that square root. And of course, guys, I cannot do anything with that on the end. That's not a product. So I'll leave it the way it is written. You guys agree? Now, am I finished, or is there some place I can use the power property? For sure here. Could I lift that 3 out front with the help of the power property on the end? So let me do that right here. Move the 3 out front with the help of the power property. ln of this. Let's get that out of the way now. I see one other term I could do that to. Where is it? This could be written as, let me squeeze it in, guys, right here. This could be written as 1 plus 3x, if I wish, raised to the 1/2. That's still saying square root. And therefore now, since I have an exponent to work with, use the power property. As I write all this down, guys, we'll leave ln of 5 the way it is. That's fine. ln of x, beautiful, leave it.
Third term though, with that 1/2, I am allowed to put that out front. And make this 1/2 ln 1 plus 3x. Let me step back, let you guys look, is that it? Is that now split up into the parts that should be split up? Keep in mind now, we start with this. And I know as a student, you'd love to just jump into it and start doing that calculus and try to find the answer. It's not gonna work. You gotta split this thing up into smaller parts, then do the calculus. And these are your smaller parts. You're done. That's all I'm asking you to do. Nothing else. One thing that some students are tempted to do, and you can't, they're tempted to do this. They say, Professor, why not go a little further and break this one up into, for an example, this? ln 1 plus ln of 3x. I'll see them do that, like a distributive property. Why not distribute ln on 1 plus 3x? And by the way, is that 1 plus 3x inside there, is that a sum? To begin with, 1 plus 3x is identified as a sum? Did I give you a sum property over here? No, I gave you a product, a quotient, and a power. There is no sum property. You can't do that. You gotta leave it like it is. And that is finished. That's this split up. Shane, do me a favor. Read the next one, please.
We've got log sub 2.
Okay, log base 2.
Base 2, sorry. Of x square root 1 plus x squared.
Whoa, x and square root
1 plus x
1 plus x.
squared. Square x.
Oh, square here?
Mm-hmm.
Like that?
Yep.
Okay. And that's it.
Yep.
It's not, the 1 plus x is not in parentheses, is it?
Nope.
Okay, no problem then. And she said, Professor, split that up. That's true, split it up the best you can. By the way, is the original a product? Is that a product? So I'm going to apply the product property. Split this up, guys, by product property. This becomes log base 2 of x plus log base 2 of the strange square root. That was a start. Now, can I apply one of the other properties, or am I finished? Yeah, the power property. If I'm clever, I can say, hold on now. This is 1 plus x squared raised to what? 1/2. And therefore, let's write this as log base 2x plus, guys, that 1/2 can be moved out front. 1/2 log base 2, and you're left with, she gave you 1 plus x squared. At this point, that's all I see to do with it. You guys agree? Isn't it tempting that maybe we could do something else with this down here on the end? So tempting, but we can't. Gotta stop. Okay. Beautiful. Shane, was there another one?
There sure is.
Uh-oh. Oh, what's the next one?
It's log with no base
Uh-oh, base 10 then, okay.
of 2x plus 3
2x plus 3.
over x squared minus 3x plus 2.
Whoa. And that's it?
Mm-hmm.
Like this?
Yes, sir.
Okay. Good. Now, which of the three properties the Waste presented to me, which of the three properties should I start out with? Quotient. So if I split this up by using quotient property, this becomes log 2x plus 3 as she gave me, and subtract from that log x squared minus 3x plus 2. Now I brought this in for a reason. By the way, if that base is missing, that's understood to be a common log base 10. Now, does anyone see why did I bring this out on the handout? Because some students may think, Professor, that's it. That's all I see to do. I don't see a way to use power property. I don't see a power unless you jump in here and that's a little tiny power I can't deal with, right? And I definitely don't see a quotient involved, I don't think. Okay. Bella, tell me One on here.
And, factor,
Beautiful.
and then use real product.
Tell me what that factors into.
X minus two,
Whether it's x subtract 2 and what?
X minus one.
X subtract 1. Now, with Bella's help, we can do more now. She's now put this into a what? A product. So I've now applied the product property on the end here. If I do, guys, in step 2, the first term must stay the way it is. I can't do anything with it. There's no property for it. Here, though, being very careful. Look at this. With her help, this is a product. So we'll apply the product property and rewrite this as log x subtract 2 plus log x subtract 1. My properties have been used. I could write the final response as, to make it look just a little better, as this. I can distribute that negative sign and have this and this. And there's your answer. There it is, split up. That's all I can do with it. I have some students who are so ambitious, they like to do more with it. You can't do anything more with it. You like to go a little further, there's nothing else to be done with it. Gotta leave it like that. Guys, okay so far? I love this. Handout's helping me. Shane, seems like I have one on here that says now, I think something about bringing it back together.
Right as a single log.
Yeah, right as a single log. In other words, I already split it up for you. That's another example in your handout. So let me go over here on the side. Shane, tell me, as we get close to a break here, what did I give? Already split up for you.
For the first one, we
Okay.
have, 2 log base 4 of x
Okay.
minus log base 4 of y,
Oh, why? Okay.
yep, plus log base 4 of w.
Now, I have another one, I think, also besides this one, right?
We do.
Now, this one's gonna be much easier. Guys, it's already been split up for you. So actually now go backwards and rewrite this all as a single logarithm with a base 4. Going backwards. Please tell me, save myself a little time here. May I take this 2 back up to where it was to begin with? Is that power property backwards?
Yes.
And I do see some subtractions, a subtraction sign, which indicates back there was a what? Quotient going on. And then I see a plus sign, gotta be careful, and the plus sign may indicate there was a product. So let's not get this thing backwards. So putting all this together, guys, definitely I'm gonna have x squared. I would suggest, so we won't make a mistake, I would bring this one in next. It says there's a product of what? Times W. And then show the quotient, what's it being divided by?
Y.
Y. And there it is, put it back together. Make sense, guys, the way you put it back together? Just taking note of those signs, quotient, product, put them where they should belong. Are we okay? Now, if you don't see it that way, on this one, before I get the last one done here, I've had some students say, Professor, can I, in the original that Shane read, can I rewrite it, rearrange my terms, and put this first, log base 4 W, and then the minus, log base 4 Y. I could rearrange the terms in the original that she gave you, can I? Now, would it make more sense now, maybe these two are the product part with a plus sign, and the last one with the minus sign means there's a quotient involved, so you're dividing through by what, y, and we got the same thing here. So x squared times w times y. Beautiful way to close down class. My last one. Shane, read that one to me, and this is a knockout, I think. Okay, here we go.
Okay, it is ln of
Okay,
minus ln of x squared minus one.
Woo! Is that my last example there, in that particular part?
Mm-hmm.
Beautiful. Right up to the break. Now I got to put all this together. Guys, the way she gave it to me, please tell me. ln of, putting all this back together, I see a plus sign indicating it's a product.
for the first two. X over x minus one times x plus one over x.
Then all of a sudden, this indicates, don't stop there, the subtraction sign indicates what? Now form a quotient.
Based on that n term, which was this.
There it is, put it back together. Now, can I simplify this? I have to simplify it. I've used the properties. And one nice thing I think about this, I think the x's cancel. And I think the denominator will factor into x minus one and what? X plus one. So we rewrite this, guys, as natural log ln. I'm left with on top there, this. And down here, I've got this. Let me step back and look at it, see if you guys agree. Yes or no? No, all I need to do is clean it up. You say, Professor, what do you mean? This is algebra. I gotta clean this up right here. So it says x plus one over x minus one. That's being divided by this. Let's think of it like this as we close down here. So all this means this. You guys agree? Which means this times 1 over this. Is that true? Just basic algebra, division. And if I do that, guys, I think, oh, I thought something would cancel. Oh, something does cancel. Well, these two cancel. The x plus 1s. So I'm left with what? 1 over, please help me, is that x minus 1 squared? Yes or no? So all this, where was it? My goodness, that she gave me here, where was it? Where was it? Up here? We have at this point, this is, geez, ln of what? 1 over x minus 1 squared. Yes or no? I know we're going to take a break here. Is that what we have right now? I'll give you full credit for that. Now, I may have taken this from the textbook. This may be one I remember from a previous class. A student did it, and they said, Professor, I checked my answer in the back, and I know what I'm doing, Professor. I know how to do logs. And the answer was not that. Can anyone tell me, even though I would accept that, can anyone tell me what the author of the textbook may have done, not him, some assistants of his. These authors never work these problems out that you guys have for exercises. They hire assistants. Can anyone tell me another way that may be presented as an answer? Even though I would take it just like it is.
Negative 2ln x minus 1.
Oh, are you saying here, Ignacio? It might be expressed like this.
Could that 1 over x minus 1 squared be written as x minus 1 raised to a negative 2? And then apply what? The power property?
So the answer in the book may look like this.
And all of a sudden, you're a good student, and you have this as the answer. What they did, they just played around with it a little bit, simplified it a little bit, and they have their answer in the other version. And I know sometimes that would bother me as a student. I knew what I was doing. I thought I knew what I was doing. You get an answer, check in the back. My answer didn't agree. They did a little bit more with it. Guys, how's all this look? Chapter 4 is almost finished. You're gonna be finished. But it's time I get it through all this. But that's almost finished. Chapter 4 is. Any concerns, questions? And also tonight we have what else? A little short quiz? Oh my goodness. A little short quiz also. I'm gonna check that time here, guys. You got 10 minutes here. Take your 10-minute break. And we'll finish this up.